When you go to a concert or you're nearby loudspeakers, you may notice that sometimes you can feel strong sound waves. The pressure that can be physically felt from strong sound waves is called acoustic radiation pressure, and that can be used to create mid-air haptics, tactile feedback that you can touch in mid-air without needing to come into direct contact with any physical stimulus. We're developing a device called an ultrasonic phased array. Phased arrays use wavefield synthesis to coordinate the phase delays of an array of ultrasonic transducers in such a way that the sound waves diminish each other in some places and add on top of each other at other places. Phased arrays can produce highly pressurized focal points that users can feel, creating mid-air haptics. And because the transducers are ultrasonic, users don't hear anything. There are many uses being explored for phased arrays, but they're still relatively new technology. As such, a lot of research is being done on how to improve interaction with phased arrays. Phased arrays are commercially available, but commercially available arrays are often based on closed-source hardware and software, and don't support modifiability and growth, which are crucial for many research purposes. We are assembling an array based on an open-source hardware model called Sonic Surface. The array is highly modifiable and has a clear development process, making it ideal for research purposes. It is a 16 by 16 board, meaning it has 256 transducers in total. We started by printing a PCB and soldering over 300 SMD components onto it. We attached all 256 transducers and programmed an FPGA to control their emissions. We use an open source software called Ultrano to calibrate the phase delays of each of the transducers. We align the peak of each phase to the rising edge of the reference signals. With all of the transducers calibrated, the board can create focal points. If we had more time to work on the project, there's a lot we would want to do. We could take steps to streamline the process, making the development of future boards much simpler. We could even create a PCB to automate many of the steps for board creation. We could experiment with different array sizes, augment the software, and test the interaction with our board using volunteer participants. The board was assembled for all these purposes, so we can rest assured that even if our team members are not personally involved in these next steps, our board will be.